Hey programmers, welcome back. Right now I want to go over an approach we can use for this sum list problem. So in this problem we're going to be given a singly linked list containing numbers as the values. What you want to do is return the total sum of all the values in the linked list. So for this particular input we should return a total sum of 20. And so how can we go about solving this? Really just reviewing a core linked list pattern, right? All you have to do here is just traverse in order through the linked list and you can accumulate a sum. So let's say we start from the beginning. If we initialize some sum variable to 0, we can also just use a pointer that starts at the head of our linked list. And what we can do is we can take current value and add it into our sum, just updating the sum. So I take my current value of 2, add it to my sum. My total sum is right now 2. Then I can set current equal to current next. I can add this 8 into my sum, getting 10. Next iteration, I can add my 3 into the sum, getting 13. Next iteration, I can add 7 into the sum, getting 20. Right? And I know that technically 7 does have a next pointer, and it does point to null. So let's say I drew that out explicitly. What I can do at this point is actually continue my algorithm, and I can make the stopping condition when my current points to null. Right? So in general, we can code this up by saying a loop like, while current is not null. If we talk about the complexity of this algorithm, it's pretty straightforward. We're technically just iterating through every node. So if n is a number of nodes, we have O of n time, roughly one iteration for every node. And then our space complexity here is actually O of 1 if we do this iteratively, right? The only variables we need to maintain are really just current and also the sum variable. And we're just going to store some primitive values in there. So we have a nice constant space solution over here. So the iterative is really straightforward. Just for complete understanding, how can we solve this one recursively? Well, if you solve it recursively, that means you have to, call your function many times. And we start with a top-level call on the head node of 2. And what this should do is really just call upon the next node, right? So I should call upon head.next. So that should give me a call to this 8 node. And that should call upon the 3 node. And that should call upon the 7 node. And finally, the 7 node should actually call upon its next, which would be the null node. And that will actually act as my base case. I think it's a really great one. What I can do with this base case, right? If my node is null, then I can just return 0, right? Think of null as if it's an empty linked list. What is the total sum of an empty list? Well, that would definitely be 0. So I'm going to plug in this return value, right? So I'm saying this call to the null node is going to return 0. When we say return, that means return to your caller. So this 0 would actually be returned into the 7 node. And what the 7 node should do is add its current value, right, its own value, into that number, giving 7. And then that returns up the stack. At this point, I return back to the 3 node. 3 can add its value with that 7, giving 10. I'm just returning that up. 8 can do the same, giving me 18. And finally, 2 can add itself into that return value, giving us 20. And that would be the correct answer, right? So there are plenty of ways to implement this one. If we solve it recursively, we're definitely going to have one call for every node within our linked list. So that would be O of n time. And the space complexity would actually be a little more than our iterative. We would have O of n space here because of the call stack, right? Typically, when we analyze our recursive functions, we should include the space utilized for making these recursive function calls, right? So O of n over here. Notice that when we bottom out at our base case, we would have, roughly like 4 or 5 things on the call stack. All right, so those are the 2 strategies I think will code up, and I'll catch you in the walkthrough video.